Good evening, and welcome to what I now realize is part 2 of All Things Surveillance. I thought that talk before by Simply Mathematics was pretty great. And thank you for exacerbating my paranoia. My name is Mark Milhouse. I am online. I'm amnesiac. I started out as a 2651 Special Intelligence Systems Communicator Administrator in the United States Marine Corps. If that sounds like a mouthful, yes, it was, and my drill instructors made me say it over and over again. I'm also a cyclist, and most prominently, I am a computer forensics investigator at a consumer class action law firm, just like he said, Edelson PC, where we investigate companies for various things. So I'm going to start out with a question. Is anyone here from an advertising company? I really didn't expect any of you to raise your hands, but thank you. Also, I might work at a law firm, but I'm not an attorney. I'm not here to give advice or opinion from a legal perspective. I'm just a technical guy. So, bottom line up front. What I want you to walk away with tonight from this talk is that as a digital society, we've built ourselves into an open ecosystem of bidding on ad placements based on geolocation and other sensitive information. The more personal information publishers provide to advertisers, the higher the bids they'll receive for their placements, and they know this. This could be used for surveillance, and I'm going to show you how a system that takes advantage of that and abuses this information disclosure might be designed. And then I want to discuss a few things that we can do to fix this, and I hope that maybe we can take that conversation forward past this talk. So if this wasn't the talk you wanted, you're free to go hit up the tool variety hour and work on your elite hacks or skills. So I'm sure there are a few of you who are wondering why the title of this talk is Phonopticon. I figured I'd explain it really briefly. It's a portmanteau of the word panopticon and phones. A panopticon is just a prison structure where all the inmates are observed simultaneously. And if this structure here on the right looks familiar to you guys, there's a pretty good reason for that, and I figured I'd take an opportunity to share.
We're going to get out of here. We're going to need a few things. The guards wear security bands to control their ins and outs. I need one.
Leave it to me.
And on the wall back there is a Warnix battery. Once the battery is removed, everything is going to slam into emergency mode. So you definitely need to get that fast. Or we can just get it first and improvise. Oh, yeah. That's a big gun.
Yeah, that freeze frame was deliberate. So, fuzzy computer animations aside, at my job, our investigative goals, we're looking for issues with privacy, security, compliance, fraud, anything else that we think might be interesting. So in order to do that, we test a lot of apps and websites and products. I'm going to focus on apps today, mostly because those tend to have the most interesting information. They have access to a lot of different sensors that computers might not. And for the purpose of this talk, we're going to look more specifically at analyzing web traffic, and specifically in Burp Suite, but generally some basic tools that we might use when we're doing this. If you're curious in how this works and you want to go try it out later, Burp Suite and Wireshark. We decompile source code with tools like Jodex, for instance. And if you're interested in finding out what's being stored locally on your phone, it's pretty easy to find some SQLite databases that you can open up with something like SQLite Browser. If you're in Burp Suite, you might see something like this. So this is a request that's being sent to an advertising network, and this would be a request that's going to pull down the advertisement for you. It's called a bid request. And in the bid request, you can see that there's some pretty specific information in there. There's a really high-resolution geocoordinates. It tells you the carrier, and It's blacked out, but in there is also the name of the app, and sometimes even the name of the page that you're on. So this is a simplified overview of the bidding process. Your phone would send a bid request along with the info, and then the advertiser would return to your phone the URI of the ad pixel, or the ad itself, the content, and then the tracking pixel. The tracking pixel would be filled with macros that your phone would then, or the ad networks would then fill in with the specific information. So then when your phone went to request that tracking pixel from whoever your advertiser's analytics company is, that tracking pixel request would have the macro filled. So when I saw the responses that had the JavaScript code, I thought to myself, well, what if we could just inject our own JavaScript in there and see what happens? Because I was curious, like, the containers that these ads are being displayed in, how do they behave? And those containers specifically they're called web views. And web views are pretty interesting. They render HTML, CSS, and JavaScript, and sometimes they can even access Flash or Java. They do this inside an Android app so that the app developer can render this type of code where they normally wouldn't be able to. And this can be dangerous because it might mean that an advertisement has access to parts of the operating system that they wouldn't normally, parts of the operating system that they only have access to because the app has requested it and those permissions are inherited. For instance, not all ads need access to your geolocation, but a lot of times your weather app has requested that permission. And so then every ad that's displayed in your weather app would then be able to access your geolocation as well. This is something that's commonly leveraged in malvertising. I'm sure most of you are familiar with malvertising, but we come across another portmanteau. It's malicious advertising, and it's exploiting loopholes in how ads are displayed to gain unauthorized access. The most common one that we're probably all familiar with is drive-by downloads, but that's not all. There are a lot, and there are a lot of easier ones than drive-by downloads. So the low-hanging fruit would be stuff that you can access just kind of natively within the browser. You might be able to get the name of the app, the battery level. You might be able to trigger the vibrate function and get connection data. And some of these things are really commonly used in device fingerprinting, which is going to be important later. But then you can also get location, like I mentioned before. And if you haven't noticed, this talk is pretty much going to be mostly about location. So how to get the geolocation in JavaScript is pretty easy. This is actually kind of a mixed up version of what you'd find if you just Google JavaScript geolocation request. But in this, what I did was I switched out actually getting the location for just getting true, false, or none, depending on whether that function was accessible or not. The reason I did that was because I wanted to run these ads myself and see what I would be able to access. So I found a cheap Russian ad platform that I didn't have to pay very much for and would allow me to put whatever code I wanted into the ads. And I bought some ads. And I got rejected. And it turns out that they don't like it whenever you go and get the ad approved, and then you start sneaking in new JavaScript. I was doing this, swapping out the code to kind of test, because I'm the kind of person that likes to test on the fly. And I was doing a lot of debugging while the ads were displaying. But of course, they fingerprint the ads. And then whenever they go and check and the fingerprint's not the same, it raises a red flag and they tell you that you can't advertise on their platform anymore. So I realized that it would be important to pass QA checks. We needed legit looking ads. They needed to be believable, but they also needed to be boring, because I really didn't want anyone clicking on them because clicks are expensive. We needed a legit looking landing page because, as it turns out, they actually do click on it whether you like it or not. So you needed some content on there, and maybe just make it HTTPS, because that's kind of easy to do. You don't have to really do too much, and it makes it look really legit. And then don't do stupid stuff. So like swapping out code, doing redirects, a couple things that will easily get you booted off of an ad network. So this is what the first ad looked like. It's kind of reminiscent of the 1990s. I decided that I would give it a redesign, and I think you guys can tell where my inspiration was. And I have a feeling that some of you in this room may have seen some of these ads before. And I'll explain why that is later as well. But this is the landing page. And if you're wondering, what's the countdown timer for? Don't worry, it resets every time you reload the page. So now you're wondering, okay, did he get the ads to run? And yes, I did. I actually got it to run on almost 100,000 phones. And I got about 1,000 clicks out of it, which was pretty surprising since my advertisements were completely nonsensical. And I only spent $40, which I thought was pretty awesome. It means that you get to test your code a lot for like no money. So what did we learn from this? We learned the ads are cheap. We learned that bypassing quality control isn't nothing, but it's also still pretty trivial. We learned that GPS access isn't guaranteed. And one thing that I didn't point out before about the Russian ad network that I was using was, even though it showed up on 100,000 phones, the information that I was getting was really inconsistent, and I was having a lot of trouble with the JavaScript itself. I'm sure all of you could probably debug and do a much better job than I did. But one conclusion that I came to was, based on the data that I was getting back, how inconsistent it was. I'm pretty sure that the network that I was using, and I'm not going to name them, was using a lot of fraudulent traffic, which is something that's kind of rampant in the ad industry. So I asked myself the question, would it be possible for an attacker to actually build a surveillance system that uses mobile advertisements to track user location? And in order to do this, we'd need a handful of things. We'd need to be able to deliver ads. And in order to deliver ads, you need a demand-side platform. It's pretty straightforward. It's just like the Russian one, but I don't want to waste my money anymore, so let's get a more legit one. You need to be able to programmatically interact with that demand-side platform, and just about every single one of them has an API, so that's covered. You need to be able to identify a target uniquely, and this is kind of natively built into these systems, and advertising ID. But now we have a handful of new problems to solve. We need to be able to get the geolocation. I think all of you already know the answer to that question. And we need to be able to resolve a target to a person and verify a person's identity. So for solving the first problem, one of my coworkers came to me one day because they knew the project that I was working on, and they brought me this article. It takes just $1,000 to track someone's location with mobile ads. And I had spent $40 and already done it, and I thought to myself, oh no, I'd been scooped. But after reading into it, I found that they had a pretty novel approach to it. They used grid-based surveillance. They bought targeted ads against different locations to a specific ad ID. And then if those ads displayed, then they would know, depending on which ad it was that displayed, they would know where the person was, kind of roughly. So it looked something like this, and this is an excerpt from their the paper from I think it's Washington State. So I thought to myself, that's cool, but nobody wants to spend $1,000, and an attacker really wouldn't want to have to build this kind of complicated system, right? But the thing that we all kind of know already, you can just grab somebody's location. So that while the grid-based system was novel, there might be a little bit faster ways to do it. We could use JavaScript like I tried before, but that can be inconsistent sometimes. You could use MRAID, which is kind of an ad industry abstraction of different JavaScript functions. And you can use tracking pixels, which obviously tracking pixels make the most sense. So for those of you that aren't familiar with how tracking pixels work, like I mentioned before, there are these macros in the URL, and it tells your phone to go ahead and retrieve the pixel that's at that location. When the user requests the ad, the tracking pixel request is also transmitted. And the user receives, or the advertiser receives that request and then can store that information for different purposes. A lot of sites have more than just latitude and longitude. Like I discussed before, they might have the app name or the name of the page that you're visiting. They might have more specific information about your phone, for instance, things that could be used for fingerprinting. And it doesn't require the target to click on the ad, which is kind of critical, because if it required the target to click on the ad, then you wouldn't be able to really consistently get the geolocation coordinates that you want. As long as the ad is displayed, then the attacker gets the data that they requested. So I don't want to bore you with a bunch of pictures of geolocations that people may or may not have realized that they were giving up, while I ramble on endlessly about how this can be used to identify people, their home, their routines. And I'm not going to dwell on the fact that this information can be used to identify vulnerable groups of people, who they are, how they communicate, and where they live. But at least now we know how to consistently get geolocations. So the next question is, how do you resolve a target to a specific person? So when you have the geolocations, who exactly are these people? And I stumbled across an article that is called Unique in the Crowd, The Privacy Bounds of Human Mobility. And these researchers studied 1.5 million people, I believe it was in Europe, over the course of 15 months. They were using cell tower resolution and roughly the range of an hour to know somebody was in this location within that range of time. And they found that 4 data points with that resolution could yield about 95% accuracy. They said in their paper that even coarse data sets provide very little anonymity. That means that if an attacker knows where you are at a certain time 4 times, then they can know with a 95% certainty that that person is most certainly you and no one else. So we have the answer to that question. Now we need to be able to verify somebody's identity. And this was one that actually I had written the entire talk, and I was having a conversation with one of my coworkers about it. And he pointed this out to me. He said, what about device fingerprinting? And so we came up with this scheme where you could send somebody the URL for a page that in the background, it would fingerprint their device. So if you already know the phone number for your target, or maybe their email address or something like that, it's probabilistic, so it's not 100% accurate. But it's good for helping eliminate mismatches. And maybe if you interacted with your target a few times, you might be able to build a profile of the different devices, maybe the different browsers they're using, so that you can be able to weed out things that definitely are not them. So one of my coworkers and I pulled out our phones, held them up next to each other, and went to this page, and it actually turned out with the same fingerprint. So it's not perfect, but it's useful. So we have that. We can use device fingerprinting to verify somebody's identity. But you're wondering, when you put all this together, how exactly does it work? We would list all known locations for a target. We would know where your house is, your work, maybe your dry cleaner, or where you go to church. We would then send advertisements to everyone that visits these locations. An attacker would add all of the suspects to a list and target them specifically. So a suspect would be somebody who has been to enough of these locations to possibly be you or be the target. So then the ads could take device fingerprints, or you could send them to pages to take device fingerprints. And the attacker could use, like I said before, a targeted link. And it's not malware, so the device would obviously let it run. And potential matches could be made that way. Eventually, an attacker would be able to narrow it down to just one person based on movements, when the target is away from home or out of town, or correlate it with social media posts to verify the identity. And finally, they can use this, once they have this and they know that this is certainly you, they can use your advertising ID to follow their target indefinitely. Because even though the ad IDs are changeable and they're supposed to be pseudo-anonymous, people rarely even know that that's an option to change your ad ID. And so it sticks for quite a while. So I'm going to show you roughly what something like this might look like. So this was built in Leaflet with a Python Flask backend. So you guys might not know this about me, but I actually live in Wrigley Field. So we're going to put Mark's house here. And I'm certain that I live within Wrigley Field, so we'll say 200 meters, right? That's about the resolution we need. And I'm home from 5 p.m. to 9 o'clock in the morning because I teleport to work. All right. And a little bit of research shows that I work in Merchandise Mart. So Mark's work. And I was told that if I didn't put the apostrophes in there, I was going to be in trouble. Now, Merchandise Mart is pretty big, so we're going to give it a 400-meter radius, just to be certain. And like I said, I teleport to work. So 5 o'clock I'm sorry, that's backwards. 9 o'clock in the morning. And I get off at 5 o'clock in the evening. All right. So now we know we have 2 points. I figured I wouldn't drag you through creating 4 of those. And I'm going to go ahead and commit that. And look at that. Now, not only do we know where I live and where I work, 2 things that we already knew, but by following that advertising ID with these advertisements that I already ran, you can see I spent some time in Lincoln Park Zoo, and down here, it's me hanging out at the beach. So this can also be used for other purposes as well. You can kind of, if you were running advertisements more generally, you might be able to just browse, see if there's anything interesting going on, who's where, who's using what. But there's also kind of a more nefarious use for it as well, which is if you have an app that you think is, let's say these people using this photo editor, we want to target them for some specific reason. Now I know where all of them are when they're using this app. And an attacker would be able to go in here and just say, this person's here frequently. That's probably their house. Or this person's over here, that's in a residential area, and then over here is probably where they work. And this is where I was talking about before with vulnerable groups. It could be used in a lot of nefarious ways. So that's scary, right? Where's the light at the end of the tunnel? How do we fix it? Well, there are really 5 main stakeholders here. We have the ad industry, operating system developers, app developers, security professionals, and users. And I know I use the word responsible there. Users aren't necessarily creating this problem, but we've kind of not done much to stop it. So for the ad industry, as owners of this technology and stewards of your customers' privacy and security, it's your responsibility to protect their information. 6-digit precision isn't really necessary for almost every ad campaign you'll ever run. There are self-regulation organizations, the Interactive Advertising Bureau and the Digital Advertising Alliance, and while they do a lot of good, it doesn't seem like their regulation is really helping in this instance, because if somebody can do something like this, then they really need to step their game up and do a better job of protecting consumers. The ad industry needs to limit the use of location. They need to ask advertisers to be more specific why they need geolocation information and why they need it to be how specific they're asking for. One thing that they can do to kind of increase the amount of safety and privacy here is add noise to geodata. Even the difference of a few hundred meters could make an enormous impact on the efficacy of surveillance techniques. They already do this, but they could do a better job of thoroughly vetting the participants. Anyone looking at the advertisements that I ran, especially at the beginning, could have said, why are you running these advertisements at all? They could do a better job of making sure that every demand-side platform is upholding their commitment to user privacy and safety. It's tempting to bow to the demands of advertisers. They're always going to want more. And we need to draw the line somewhere. Requiring advertisers to set perimeters instead of disseminating data raises the cost and difficulty. What we need to do is move the bidding algorithm back into the black box and stop disseminating this information forward. I came across an article that I really enjoyed, a paper called Android, and they talk about privilege separation for applications and advertisers in Android. And pretty much the gist of it is that they're asking Android to build a feature where there's two different geolocation permissions. There's two different permissions for different types of data collection. There's one for the application itself, and then there's one for the advertisements that you would run inside the application. This is kind of a breakdown of how they're proposing it would work. And I think they did an excellent job of it. And I asked around to see if Google ever contemplated incorporating this into the Android operating system. And all I heard was that it never really got brought back up again. App developers. Protect your customers. You're the first line of defense. A lot of times people say this, and I don't know if this is really the attitude. I've never worked for an app developer, but the attitude I think that you need to have is that all third-party code is dangerous. Make sure that you employ security professionals to perform both internal and external audits. And one thing that I think we could do is offer alternative forms of monetization. Facebook says that they'll never charge money for their service, but maybe a paid opt-out is just what we need. This could exaggerate economic inequality, sure. So offering your entire content unsupported and then only monetizing premium features that aren't necessary for the function of your app could be one way that you could solve that, but this is definitely something that I think we need to explore more. I don't own a tech company. I don't report to investors. So I can't say that I know all of the solutions to these problems or all of the arguments, but I think this is a conversation that we definitely need to have. So now it comes to us, right? Security professionals. We are the eyes of the company, and we should be advocates for their customers. We need to fight for more reasonable collection practices, asking the question, when do we need to collect this information, and how are we really supposed to be disseminating it? Make noise. Don't let your clients and employers be blinded by profit. Encourage them to stand up for their customers. And when you're testing, make sure that you use human analysis. One thing that I think a lot of people see whenever they're testing these apps is that information can be encoded or encrypted. It can be broken up and displayed in chunks. It can be transformed, and it makes automated testing really hard. And something that I'm going to drill over and over, step up and support legislation and regulation that restrict the collection and distribution of sensitive information. So users, we're users. We're also security professionals, but we're users. Add and script blockers can be handy. I mean, this isn't a solution. The problem is not on the user end, but in order to protect yourself, you could use false accounts. You can use GPS spoofers. You can disable location services or even refuse to use abusive apps. And pretty much all of this stuff is really inconvenient. And being somebody who doesn't have a Facebook account, I can say that it's really inconvenient. But one thing that we can also do is support privacy legislation. So I have here a list of organizations that are pro-privacy. It's a long list, and I'm probably missing a majority of the organizations. But there's the Digital Privacy Alliance, the Electronic Frontier Foundation, and their group of other organizations that's called the Electronic Frontier Alliance. So if you are part of a privacy organization and you're looking to connect with others, then that's one organization that you can connect with. The Center for Democracy and Technology, American Civil Liberties Union, Lucy Parsons Labs, the Chicago Committee to Defend the Bill of Rights, EPIC, Access Now, the Brennan Center for Justice, Future of Privacy Forum, the Center for Media Justice, and Free Press. And there are many more after that. I have a list of resources that I used when I was researching this topic. And if you're interested in learning more, this might be a good thing to take a picture of. In conclusion, us sitting in this room at this conference. Oh, sorry. Did you want to? That slide? Yeah. Too fast? Yeah. Okay. I'll wait for the flashes to stop. And you know what? I'll tweet this out too. So just look for Amnesiac, and I'll have a somewhat shortened version of that list. We ready? Okay. We sitting in this room at this conference and all of the conferences like this that we attend, we represent a comparatively tiny collection of people who truly understand the dangers of this system. This is a real problem that affects every member of the digital society, and it's not going to get better. We need to improve our own systems, and we need to hold our service providers to a higher standard. And I'm going to leave you with one more movie clip.
Beautiful, isn't it?
Beautiful, unethical, dangerous. You've turned every cell phone in Gotham into a microphone.
And a high-frequency generator receiver.
You took my sonar concept and applied it to every phone in the city. With half the city feeding you sonar, you can image all of Gotham. This is wrong.
I've got to find this man, Lucius.
At what cost?
The database is now key encrypted. It can only be accessed by one person.
This is too much power for one person.
That's why I gave it to you. Only you can use it.
Spying on 30 million people isn't part of my job description.
This is an audio sample. If he talks within range of any phone in the city, you can triangulate his position.
I'll help you this one time. But consider this my resignation. As long as this machine is at Wayne Enterprises, I won't be.
When you're finished, type in your name.
And another intentional freeze frame. Thank you very much. Any questions?
I guess since I got here first, I'll jump in. So I'm the general counsel of an advertising technology company, and
Oh, hi.
hi. I've spent the last 2.5 years that I've been working for my employer, getting rid of data we didn't need, and we've seen no decrease in our profits at all for doing that.
Thank you.
I wanted to ask you, though, we notice on our network about 20% of the people have enabled limit ad tracking on their iOS device or enabled opt-out of interest-based ads, which is the same terminology on Android devices.
Right.
And you didn't provide that as a tip for how to shut this down, but it seemed like just going into your settings and enabling that would have opted anybody out of your type of surveillance. Is that right?
You know, that's a really good point. I didn't have an opportunity to test that. I have a feeling that that might not thwart it as much as you think it does, but I think that's definitely something that needs to be looked into.
Cool. Thank you.
Thank you.
I only wanted to ask, you mentioned the ability to change your ad ID, and I wanted to know how to do that, and could an app be made to kind of do that on the fly?
That's a really good point. I will tweet out a link to instructions that I'll probably find on Stack Overflow, but I will definitely tweet that out for sure.
Thank you.
Hi, great talk.
Thank you.
You briefly mentioned the fraudulent traffic in ad networks. Did you explore that at all? Did you find out, like, that 1% of clicks, right? Like, do you think that was bots? Like, do you have any sense of location from that stuff?
You know, I have no idea. And to be honest, like $40, it's not nothing, but it got me the results that I was looking for to a certain extent. Like I still got to test what I was doing. So it didn't bother me that much that I saw problematic things in the traffic. So I just didn't think to look any further into it. I would say that's definitely another thing that really needs to be looked into. And I know of some companies who are dedicating their entire being to investigating ad fraud. Off the top of my head, I couldn't name any, but there we go. And actually, I would probably say that just about any advertiser probably has a pretty strong fraud department that they're looking into it. I'm getting a shake of the head here, so I take that back. I was assuming that, but maybe that's not the case. Any other questions? All right, thank you.